My colleague Jim and I will be talking to you about how to avoid mistakes when doing a migration. Sometimes, it's very ugly to say failing in the title of a presentation, but it is how to avoid failing, not how to fail. Okay, so this is very important. Just a quick introduction. We're both colleagues here at Snowflake. Jim is part of the professional services team. I'm part of the Snowflake product team focused on migration accelerators. And we both have a lot of gray hair because of migrations that we have been doing over the years. So Jim, why don't you start by telling us why should we migrate to Snowflake?
Okay, thank you. And I do have gray hair, I just color. Try to keep my boyish looks if I can. Obviously a lot of folks here are here because of the reason of what Snowflake promises, and you're expecting to get a favorable ROI for whatever reason that you're migrating to Snowflake. Usually it's to be faster, to be better, cheaper, to be able to do things and exploit the feature set that Snowflake provides, to be able to do things that you couldn't possibly do on your other platforms. And the efforts that we've been involved with over the last several years have been how do we help clients move quickly off their legacy platforms onto Snowflake. And with that, we've developed a number of processes, utilities, tools that help us to accelerate the migration of your workloads onto Snowflake. And some of the examples that you see here on this slide include some pretty dramatic numbers. Being able to migrate entire database workloads in an ecosystem in 53 days, be able to reduce your expense by 84%, and improve the performance of your processes from days to minutes or even hours to seconds in many cases. And these are not just arbitrary numbers. We have done this, and we've even done things better and faster than this, but let's also temper expectations. You're not going to migrate in a state of 28 Teradata boxes in 53 days. It's going to take some time planning, and that's what we're here for. That's what we want to talk to you about, is some of the things that you can do to improve the success rate and minimize the amount of surprises and issues that you need to mitigate in the process of doing a migration. So I'm going to do a quick poll here. First question is, how many of you have done a migration to Snowflake so far? Raise of hands. Okay, that's good. That's about 60, 70% of the group. How many people here have done a migration on any platform to any other platform? Okay. How many have done multiple database migrations? Wow. All right, look around. These are your buddies. These are your friends. These are the people who've done this before. And this is also a certain amount of suffering that you've all been through in this process, I'm sure, because there are things that you didn't anticipate that you discovered as you went through it. I did my very first migration back in 1985 when I was migrating RMS 11 index sequential files into RDB, which was acquired from Digital Equipment Corporation by Oracle. And I've probably done over the last 40 years somewhere in the neighborhood of about 150 to 200 migrations over this time over a variety of different platforms. So yeah, I do have some scar tissue. How many of these migrations experiences you went to were painful? Okay, so look around you with the hands up. This is your support team. All right, we're all charter members of this, and it is important because if you've done this in any degree of scale, size, or complexity, you have run into something that became an issue, became a problem, something you probably didn't anticipate and didn't plan for and didn't mitigate. So when we talk about migrations, we do look at things holistically, and the questions that always come up with a migration is, who's going to do the work, what's the approach, how long is it going to take, and what's it going to cost? These things always come up at the beginning because you need to make sure that you've got an alignment across the customer base, the SIs, or whoever it is that's involved in the work, that we're going to get this done, and we all have an understanding and an expectation about what this plan will look like. So when we look at the components of a migration, big part of this is on the left-hand side. It's the analysis, planning, and design, making sure that you've done as much pre-work as possible. Now, it doesn't need to be to the point of analysis paralysis. You know, some of this stuff is going to be fit for purpose, how much time and effort you actually put into this. But it should be there to cover the bases of what you need to do in a migration. And if you look at the middle section here, you'll see that there's environments and security, there's database conversion, there's data integration, there's reporting and BI, the inbound and outbound integrations, your platform security, data consumption. And we didn't list these in a linear way because they don't need to be done in a linear way in every case. Sometimes you'll actually be able to do a lot of this work in parallel. And part of that is, again, in the analysis, planning, and design, figuring out ways of condensing the activity, because the smaller window that you have in order to get things done, the less likely things are going to change during that window that would derail you. We've all had the meteorite come from the sky during a very long project, and things just happen, and you know, the soccer ball gets kicked to another corner of the field and everybody goes running towards it. These are the things you have to prepare for and make sure that you've got some intestinal fortitude to get through. And you'll notice on the right, we have the deployment and the optimization. Once you actually do the cutover and you're running on Snowflake from your legacy platform, you're going to want to give it some attention because it's important to make sure that your workloads are running optimally or near optimally because you're now on a consumption-based platform. You might not have been previously. And once you do have that change, you fundamentally have to look at, you know, are your queries running predictably? Is your consumption where it needs to be? If you do it right, Snowflake will be the cheapest and fastest platform you've ever been on. But you can screw this up. Anybody can write a query, they'll dim the lights in the data center. And this is why it's important that you focus on the things that are important and make sure to keep lists of risks and mitigations that you're going to be going through in the course of this execution. So we had a list on that last slide. I'm going to do another poll here, again, hands. Let's talk about what was the most difficult thing that you had in your migration, the most painful experience that you can think of. Where was the greatest challenge? Was it an analysis and planning? Any hands here?
One.
There's a few. I see a few. All right. Was it in the environment, configuration, security, access controls, those type of things? All right, not a lot. Inbound integrations, your ETL processes. Definitely seeing some more there. Okay. What about the database object conversion, your tables, views, stored procedures, functions, triggers, et cetera? Let's see a few hands on that. Data migration and data quality, you ran into problems there, okay? How about the outbound integrations, all your reporting estates and the consumers? All right. Data validation and testing, that's a big one, isn't it? Optimization, after you got things running, getting them running well. And then I've got the catch-all, other, which is non-technical related issues. This could be organizational challenges, this could be project management and oversight. Okay, we got a few there. There is no one answer, obviously, about where the problems really lie. It's going to vary from project to project. But we do see some relative common patterns with the execution of a migration. And what you'll notice here in this pie chart is that the top three are going to be your data ETL, your data migration and quality, and your testing and validation. Those things typically will take up the big chunk. At one point in time, a few years ago, one of the biggest chunks here was the object conversion of the database, but there's been so much automation and so much parity that's been developed, we really closed that gap with automation in the process. So when we're doing a migration, we do have a playbook that we follow. And the playbook is technology agnostic, but we do use technology-specific tooling to help us with the acceleration. We always start off with discovery activities. There are going to be things that we need to know, things about your environment, the complexity, the size, and methods of analyzing and assessing how big of a problem this is going to be and how much of a challenge we have. Then the assessment and planning is the next phase, where we get into effectively measuring twice before we cut once, knowing what the activity effort's going to be, who's going to do the work, how it's going to be broken down. And that is intended to make sure that the delivery and the execution follow to a plan that's predictable, and we are able to mitigate those risks as we execute. Now, one of the things I want to jump off to is another set of sections here about key considerations, key decisions, and best practices. All right, so one of the key considerations you have to have is what exactly is the alignment here? Why are you doing the migration? What are you trying to accomplish? Make sure that there's complete alignment from the executive team that's sponsoring this all the way to the execution team that's delivering it. Are you doing it because you have a hard deadline that you need to meet? You have to get off of a system by a certain date. You don't want to have another renewal of an expensive platform. You don't want a tech refresh. Maybe you have a cloud-first initiative in your organization. Everybody's different. But we've had cases where clients have come to us literally after Thanksgiving saying we need to be off our Exasol environment by the end of the year. That year, not the following year. And that was one of the deliveries that we did that was under 30 days. We were able to do it. Now, it turned out that happened to be a fairly pedestrian migration. There wasn't any stored procedures to deal with. We had tables, we had views, we were able to migrate the data, validate it, and the customer was very competent in what they were doing, and we were able to execute it. But certainly, you don't want to be in a situation where you're given less than 3 weeks to actually do a migration of any importance. The business case and success criteria are very important as well, making sure that there's clear understanding about what the expectation of success really means. Is it that you're going to be faster? Is it you're going to have all the workloads done? A lot of times with agile development and larger migrations, you're going to be breaking this down into a variety of different work streams, and you're going to be executing them to a particular schedule. There's also an important expectation if there are service level objectives or service level agreements that are in place, making sure that you're actually meeting them. In some cases, you may actually want to make sure that you're taking some of the more problematic areas, doing a POC or an MVP on those first, make sure that you're able to hit those key things, because that informs the rest of your migration. The other thing to note is going to be what's acceptable as far as tolerances are concerned for differences between the platforms. Certain things that you have to understand when you migrate from one platform to another. You may be dealing with different character sets and trailing strings. You may be dealing with floating point numbers, which get approximated differently on different platforms. So you have to be aware of these things in advance to know what is acceptable and have that criteria understood between the development team, the testing teams, and ultimately who's going to accept the migration. It's important to have a current and future state architecture. Understand where you're starting from, where you're going. And the key thing there is really knowing how much in your architecture is going to change from the current state to the future state. A lot of times it's not just changing the database. It's also going to be the repointing, the refactoring, or the replatforming of your reporting environments, potentially your ETL solutions. And sometimes you don't have much of a choice. If you happen to be on certain products, they don't support an upgrade or working with Snowflake without having additional types of licensing and other things that you need to take into account. One of the things that we highlight here is what we call move and improve. And what we mean by that is that a lot of times what you can't really do is within the time frame that you've got for a migration, do a massive redesign of what you're trying to work with. A lot of times it's really best is to take what you have, lift it and shift it onto Snowflake, warts and all, carrying some of that technical debt, but it untethers you from the legacy platform. You can then shut that down, move on, and then leverage and exploit features that are on Snowflake to do the modernization that you want to do. You'll be able to use things like our elastic compute, zero-copy cloning, data sharing, things that weren't available to you on the legacy platform. And it does help you accelerate in that modernization process. Knowing some of the data platform differences and having experience and expertise of people who have done migrations, you know that when the very first migration that you did, I guarantee you ran into something you didn't expect. After you've done a few of them, you learn to have your antenna up and you start to build a muscle. And most companies that we work with typically are fit into two buckets. One bucket is going to be, we do this all the time. We do mergers and acquisitions. We're constantly acquiring other companies and migrating and standardizing their stuff into our environment. The other companies, migration is once in a blue moon, once you're forced to do it, or an organizational change. A new CIO comes in and says, we're gonna go cloud first and we're gonna change everything on you. And it's in those particular cases, it's important to make sure that you've got at least some level of expertise with people who've done migrations before, because they can help you with that. They can help you identify the things that you might have blind spots for. So another key consideration that we like to target here is basically identifying areas of complexity. And this isn't just a generic statement. This is like a scorecard here to basically understand whether or not you've got a coefficient of complexity that you have to deal with across the entirety of your project. You know, things that are listed here include, like, are you working on-prem and you have a constrained network bandwidth? We've had clients that have had, you know, very, very large estates, hundreds of terabytes of data, and their network connection to the AWS environment where they're hosting a Snowflake environment was less than 1 gigabit. It's going to be a long time to get that data over that way. All right. So you start adding in these things that potentially are going to drag you down. Things that are listed in this, and it's not a comprehensive list. You would be creating your own. But these are the things that are friction. These are the things that are going to, you know, slow you down, impact your ability to get things done. And you need to account for that as part of your contingency plan in a project. Some of the key decisions you're going to need to make with your migration involve, are you going to do a lift and shift? Are you going to do a selective lift and adjust, or something that's a little bit more pragmatic? Or are you going to do a complete redesign? I've highlighted complete redesign in red for a reason. If you're going to do that, you're basically building something net new. And if you do things like change your data model, all your integrations are going to have to change. Your reports won't work, your ETLs are not going to function. Any of the things that you've already depended upon effectively are out the door, and you're going to have to build all net new. Some clients have decided to do that, but if you're doing that as a project and you're going to use the same resources that are currently keeping the lights on in your organization, you're going to dilute your focus, and often those types of projects are not all that successful. The lift and shift, as we said, is probably the easiest, because you're basically doing an exact comparison. You're basically bringing it over, and you'll be able to show that what you've done on Snowflake looks exactly like what you've seen on the other platform. If you do a pragmatic lift and adjust, where you're selectively changing certain things, usually you're going to be doing those selective changes because they're to your benefit. And what I mean by that is that they may de-risk or eliminate some of the work that you need to do. Big opportunity here could be, today you're subscribing to a third-party data service, you're bringing it in, you've got a pipeline to ingest it and process it and transform it and make it available. Maybe that same data service is available on our marketplace. You just switch your subscription over to that. The data is available to you in a data share. You can eliminate an entire pipeline from your migration path. And similarly on the outbound side, if you happen to be packaging up information, putting it into a file, sending it off SFTP to another partner, if that partner happens to be on Snowflake, maybe you can just set up a data share and make that same available data to them. There are a number of options that you can do there that are fairly helpful, and you know, and sometimes there are going to be some elements in your migration where you really just don't want to take something that was so poorly designed and bring it over into Snowflake, and you want to redesign that element in the process. But if you can stick mostly to a lift and shift, you can really accelerate and utilize a lot of the automation tooling that we have that, you know, Federico will be showing here soon to really get you going and get you up and running on Snowflake. Now, the implementation approach is going to be variable from client to client. Usually when we see agile development going on, you're going to be migrating, usually in a focus of system by system, subject area by subject area, workload by workload, whatever makes sense for your particular organization. And most organizations also have a parallel run. You're running on Snowflake, you're also keeping your legacy system up and running, and you're comparing the results until you have a comfort level where the folks that are doing the user acceptance testing can say, yep, we're comfortable, it's running the way we want, optimally within the tolerances and the acceptance criteria that we've laid out. But a big thing here is going to be also in the key decisions about repointing, refactoring, or replatforming. Some of those decisions may be inside your influence and maybe outside of your control, but when those things come into play, again, you have to plan for them. And having expertise in the project, it's really important, I think, to have somebody who knows their way around migrations, and particularly how to get best practices into what's running on Snowflake. There are certain patterns that we often see in projects that involve migrations from Oracle or Teradata, We see a lot of row-based processing or trigger-related activity. Those things are not going to scale well on Snowflake. But there are workarounds, there are methods of building or emulating that same kind of result on Snowflake, and that's where getting an expert involved will help you out. So one of the best practices that I'm a big fan of is what I call a SciPoc document here. And what SciPoc is, for those of you who have ever had any kind of Lean Sigma experience, SciPoc is an acronym for suppliers, input, processes, output, and customers. And by laying this out, it allows you to build an inventory of where you're getting your information from, all the organizations, HR, finance, marketing, research, et cetera, or third parties that you get information from. And then the inputs are the mechanism by which that data gets to you. Is it by file, RSS feed, stream, ETL jobs? The processing that's done within your database to transform, curate, enrich that information, build out analyses and insights. And then how are you producing that to the people who consume it? Are you also providing services? Are you building out dashboards and reports? And who is the community that's going to consume it? And this is really important to go ahead and document all these things to make sure that you have a completeness of everything that's involved with your migration. We've often seen this happen, something is forgotten. And in some cases, it's something that's mind-boggling. How could you forget about that application? How could you forget about that user community? How could you forget about that business unit? Doing something like this is important to make sure you're socializing it and make sure that you've got all the coverage that you need. It also becomes a burn-down chart for the stuff that you need to prove out as you do the migration. So it's an effort well worthwhile. And once you have all that stuff, the next thing you need to do is basically make sure it's complete, and then you can rationalize out the things you don't need. And in the areas that we typically look at here, your inbound integrations, your ETL, ELT, your pipelines, maybe some of them are no longer used. Maybe those sources no longer exist, but they happen to be within your inventory because you haven't deprecated it. It's still, from a hygiene standpoint, one of the things that we see that's listed here is your outbound integrations, your BI platforms. In most of the implementations I've seen of a migration, the reporting environment in most organizations was done in a federated manner. People have built out a ton of reports. They get built once and they stick around forever. Nobody ever eliminates them, even if they're no longer used, the department isn't there. Going through an effort to cull that and groom it out and rationalize it will save you in efforts of testing and in the migration planning altogether. So it's really important to look at federated development, non-IT business units. Sometimes you have a whole community of people that are depending on your environment through no other things than access databases and ODBC connections and Excel spreadsheets, and you don't even know about them, but they're using these assets that were not developed by IT or governed by IT to manage and run critical operations in the business. There are ways to get that information, looking at query histories and so forth, but again, go back to that SciPoc and make sure you understand the community of people that are using your systems. We talk about source DDL and historical data. Maybe you don't have to bring over the petabyte of information. Maybe a number of a lot of that data doesn't need to come. It's met its retention cycle within your company and can be eliminated. Don't bring that data over. Similarly with your code, when you do the DDL assessments, we can look at dead code, duplicate code. I've seen migrations where we had an Oracle Exadata platform where there were 19,000 functions on that platform. It turned out there were only 4, but they were replicated 600 times a piece because it was a multi-tenant environment. Well, you only have to calculate out the effort of doing those 4, not 19,000 of them. But the fact is that there was a duplication and proliferation of code that wasn't necessary. So we have tooling and we have ways of determining the level of effort, looking at your code complexity. Tooling like you'll see with SnowConvert here shortly helps us understand lineage of code, dependencies, completeness of code. It'll also highlight functional differences. It'll highlight areas of performance that you might need to address. All these types of automation tools have been developed because there's a need for them. And necessity being the mother of invention, there's a reason why these things have taken off and a big part of what we do. Data volumes, are we dealing with gigabytes, terabytes, or petabytes of information, and what does your pipeline look like of moving data? These things are also important to take into account. So it's a broad coverage. And just to wrap up here with my last slide, some of the best practices that we do recommend, for project risk and cost mitigation. Again, I'll reiterate, having applied expertise in migrations and people who understand the technologies that you're working from and to are very important. Project management, I know this sounds like a PM 101, but the fact of the matter is the bigger the program that you're managing and the project that you're working with, it's really important to make sure that collectively you understand how to escalate, how to communicate, make sure that you're transparent. If there's a problem, bad news does not age like fine wine, it ages like milk. So get it out on the table, get the group of people together, have them all look at it, and you might be surprised by some of the great ideas that come from the least expected organizations and people that are involved. Training is one of the things that I think is almost understated with any kind of migration to Snowflake. Even though Snowflake is an easy-to-use database, and we always tout that, there is functional differences about the platform, and the more people that we have trained when we work with on a migration, the faster and more efficient and more effective that migration actually is. You get these people, they end up becoming more of an accelerator and not groups of people that are trying to carry over legacy knowledge of what their old platform did versus what the new one does. Use of accelerators, obviously, POC and MVP out, prove out the more difficult areas, make sure that everybody is comfortable with those things, because if you can get the more difficult things out of the way, there's going to be a higher degree of confidence in the schedule and the project effort to do the rest. And lastly, the parallelization of work streams. This is another thing that it kind of is a bit of a mind boggler to me, but often what we find is that people will start to look at a migration linearly. Like, I'll start off by building the database, I'll start to ingest it, and then they'll do all this work, and then they leave reporting to the very end. And it's one of the things that you can handle and accelerate very quickly. Very first thing you do, get a snapshot of your data, unload it from your legacy platform, load it into Snowflake, kick off your reporting team now to go ahead and test all the reports against your environment, do a break-fix type of work if you're going to just simply report it. Those people can be working on their own while you're going ahead and developing the new pipelines. The last slide, just quickly, a RACI chart is always extremely important to make sure you understand who's going to do what, everybody understands their lanes, who's going to be consulted, informed, responsible, and accountable for the different activities. All these things are important to be successful in a migration.
I wanted to show you our main tool to accelerate migrations. And but before that, I want to thank you, Jim, because I mean, all of the advice that Jim provided to you actually really comes from experience. And as he said, sometimes it might seem Project 101, but the amount of time that we have seen it not happening is very large. So let me tell you about SnowConvert. SnowConvert, and by the way, I see a couple of people that actually just saw this demonstration in the previous session that I made, so bear with me. But in that case, it's going to be very well imprinted in your head after you see it twice. SnowConvert is an on-prem tool, and I'll show you how to access it in a second. That you can install on your machine, and that actually allows you to do the migration of your legacy platform into Snowflake. At this conference, we're actually launching an evolution of SnowConvert that we're calling SnowConvert AI, which is an enhanced version that takes advantage of artificial intelligence to actually improve the results of the conversion even more than before. So let me start by creating a new project, and you'll see how it works. I have a typical Microsoft database called Northwind. For those of you who have SQL Server, you probably have seen it. I have a number of platforms that I support, from Teradata, Oracle SQL Server, Redshift, BigQuery, Synapse, and we are trying to add more and more platform, as fast as possible. In this case, I'm going to give you a demo about SQL Server with SQL Server, and you have an access code for SnowConvert, and if you don't have an access code, it's very easy. You just go and request one. You immediately get an email with an access code. You just put it here, and you can continue to use SnowConvert. There are two ways in which you can get data into SnowConvert. One is by connecting directly to your source database. In this case, we can connect directly to SQL Server and extract the DDL from the database catalog. Or if you have your code in a Git repository, or if you have extracted some other way, or if you have things like SSIS, Power BI, or things that are not really part of the database, you can just put them in the directory and point SnowConvert at that. In this case, I'm just going to connect to SQL Server and extract the information directly from the database catalog. And actually, I also need to provide a working directory for SnowConvert. I'm just going to put it here, and now I'm connecting to the database. What's happening now is that SnowConvert connects to SQL Server and extract all of the information that is in the database catalog. So it found the Northwind database, the schema, in tables and views. And in this case, I'm just going to select the complete database for extraction, but you can select a portion of the database. Something that is very important is that if you select just a portion of your source code and you put it through SnowConvert, you have to remember that SnowConvert, at its core, it begins as a compiler or as a transpiler. So it requires all of the dependencies to be migrated at the same time. If you have a stored procedure that is referencing a table and you don't provide SnowConvert with the definition of that table, then SnowConvert is not going to do the best possible job, just because it doesn't know the data types of the columns or anything like that. So it's important to migrate all of your database at the same time, or not the database, all of your use case at the same time. In this case, we can see that it extracted a few objects, and then we can continue. A requirement that we have had over the years is that customers, they like to implement new naming conventions when doing a migration. And this is something that we offer. So if you want to just change the name to one object, you can just come here, make a change. Or we also offer some bulk mappings. So if you want to add a prefix or a suffix to your objects, just to make it more friendly to your destination. And certainly you can change the name of the database and the schemas. Let me now start the conversion. What's happening here is that the transpiler inside SnowConvert is actually scanning the code, parsing the code, creating an abstract syntax tree, creating a symbol table, and then using all of that information to actually convert the code as best as it can, so that it is semantically equivalent in Snowflake. So again, this is not just a glorified find and replace. This is a real compiler that is working to do the source code translation. And then we can look at some of the results. In this case, again, I just want to point out a couple of numbers here. One is the code completeness score. This is, again, in this case, I extracted the whole database. So hopefully all of the objects were there, as in this case. And then I have all of the dependencies of my objects together. If you don't, SnowConvert is going to help you and it's going to tell you these are the missing objects, and maybe you can just go bring them into scope and then remigrate. Again, SnowConvert is not going to stop, but it's not going to produce the best possible results. I've seen many times customers just, let's migrate all of the tables. Okay, fine. And then, okay, now we'll migrate the views. But the views depend on the tables. If SnowConvert doesn't know the data type of the original columns, it's not going to do the best possible job when translating views. And the same for procedure and functions. Something else here, just very quickly, it's going to give you a summary of the objects that were migrated, how well they were migrated, and we actually have a combination of lines of code migrations and objects that were migrated completely versus objects that require some additional verification. We also have lots of additional reports provided by SnowConvert, and there are many reports. One that is important is the issues report. So when building SnowConvert, we actually try to convert the code as best as we could, but we also detected places where we could not perform the complete conversion. And in that case, we actually added some messages inside the generated code as comments, and those special comments actually are very helpful to the migration engineer to know how to do this last mile work that is necessary to finish the job. So actually we put a lot of attention not only in converting the code, but actually in also in telling you what issues you may find in the code. And this issues report is just a summary of all of those issues, and is actually a very good input when you're trying to determine what is going to be the effort to finish the migration job. But in this case, the next step is what we call AI verification. And this is one of the places where we're actually introducing artificial intelligence to help us with this job. What is this AI verification going to do? Let me just start it, and again, I'm going to do it on all of the objects, and I'm going to verify the code. Oh, I actually need to connect to Snowflake because I'm going to use Cortex AI to help me with this process. And apologies, I'll change my password very shortly, so don't copy it. I'm connecting to Snowflake to use Cortex AI to help me in this process. And let me just start this process, and then I'll tell you what it does. So what we are doing is that we are actually creating test cases that the artificial intelligence is creating test cases to run the objects both on the source platform and on the target platform. We're also generating synthetic data so that those test cases can actually run. And then we look at the results, and we see whether the results match or whether the results don't match. And then if they don't match, the artificial intelligence is going to go in and try to fix the code, and if it can, and then verify it again, and then provide the results. Again, we are getting very good results with this. It's not perfect, and just let me give you an example. This is one example where you can see here the original output of the test case that was generated, then the converted output by using just a transpiler, and then the output once the artificial intelligence actually fixed the code generated by transpiler. And there is a whole explanation here, but I wanted to just show you an example of this. This is the example. So this is the source code. It's a very simple procedure, yes. And you can see that this procedure has a fixed length character in SQL Server as one of the parameters in the input. And this parameter is utilized to do just a simple where clause, right? However, in Snowflake, we do not have fixed length characters. So what happens if you have a string with just 3 characters? In SQL Server, you would have 3 characters and 2 spaces. In Snowflake, you would have only 3 characters. And so when you do the compare, it wouldn't match, okay? And believe me, and Jim can tell you that, finding this type of error when you're doing user acceptance testing is actually very painful, because then you have to go back and fix it and rerun all of the test cases. And so the original transpiler just, put the same translation, because this is syntactically correct, and in general, it's okay. However, artificial intelligence actually fixed this problem and actually added an RPad when you're doing the compare. So now I am comparing a string potentially with 3 characters and 2 spaces correctly, and then it's going to match, and then the results are going to be okay at the end. So this is just an example. I mean, it might seem a simple example, but this can save ton of time when you're doing a migration project. Once I've migrated and verified all of my objects, then what I have to do is that I have to go and deploy them in Snowflake. And to do that, I'm just going to select again in this case, I'm going to select, actually, let me select just the tables, otherwise it takes too long. I'm going to take all of my tables and deploy them in Snowflake. And we can see here, let's let it finish. It's now deploying the objects, and essentially deployed one database, it deployed one schema, and it deployed 13 tables for a total of 15 objects. And now I can go here. This is the account that I'm connecting to, and I can just do a simple query, and you can see, what did I do? You can see that there is no data in this database. And then I go back to SnowConvert, and again, now what I want to do is that I want to migrate all of the data inside those tables, just to finish the whole cycle. And again, I'll show you that it migrated it, but what I'm showing you today is that with a tool like SnowConvert, and now SnowConvert AI, you can do an end-to-end process, an end-to-end migration. And this is a very good acceleration of the process. We've used SnowConvert for over 4 years on some of the platforms. The conversion rates are actually quite good if you use it in the proper way. And now with the addition of artificial intelligence, we're doing that even more. We're also announcing at this conference that we will be adding support for SSIS for SQL Server, so that some of your ingestion pipelines can be repointed and eventually replatformed to Snowflake, as well as for Power BI, where you can do also some Power BI repointing, so that the data doesn't have to come from SQL Server, it can come from Snowflake and generate the same exact report as before. So again, this is just to give you tools to accelerate and to make the migration process less painful. Just let me rerun the query that I ran a minute ago, and you can see that there's now data inside Snowflake that came directly from the SQL Server. So this is really the demo that I wanted to show you, and we can go back to the original presentation and advance here. This is what I just showed you. And this is just a summary of what we showed you. So SnowConvert AI now is really supporting the ecosystem conversion. So ideally, we are going to be able to migrate code from the ingestion all the way to the reporting. And again, it's end-to-end data migration experience that is included here. And again, like last week, one of our customers used this tool to migrate 130 tables and 75 gigabytes of data in just 1 day, starting from extracting the tables and the data all the way to something that can run in Snowflake. So this can really accelerate the process. Of course, if you have 2 petabytes, the problem is different, and you have to do additional consideration, and we have other tools that can support that type of process. But this is what we wanted to show you today, and here are some resources, if you want, of a couple of webinars that we have done that can help you, determine what is the effort to do the DDL migration of a database, and also, some additional pointers on what to avoid when doing a migration project. And with that, thank you very much.